Hey guys, um, today we're going to do some improvement on our code. So last time we refactored some bits, so now we've got a somewhat nice looking code. Yeah, that's the file. So what we did is we refactored this reconciliation JS, and now it's pretty much able to render very easy JSX, like this div with a text element of app, and as a result we got this app here, and we can see that we have this div under the root. So what I want to do is I want to be able to modify this div. Let's just think about it, that in any React app you have like either events or some subscription from the backend, or some I don't know, just some basic fetching. Like you don't have to have subscriptions, but just simple AJAX requests, and sometimes later it comes back and modifies our structure. So there are a lot of things that can cause modifications on the GSX. That's the whole idea of having a web app, and we wanna be able to reflect on these changes. So we don't just want to have a static HTML, but we also want to be able to modify our JSX, and we want to represent those changes obviously sometime in the painting phase. So if we go to the reconciliation algorithm, what we have is we hard-coded the painting phase when you have this commit over. So all we do is we just simply append the child, but that's not always going to be the case, right? So we can either have situations when we want to remove the child, and also when we want to leave it as it is. I mean, we don't even want to append it, and neither we want to remove it. We just want to change the properties of the given host node, or we can say like native DOM element. So there are tons of things that we can do, and if you think about like just a simple scenario when the user clicks on something, then it can trigger something in the application, and then that can, for example, it can change some React state, and after that it triggers a re-render. So some part of our application gets re-rendered with the new state, and that can change like colors in our application, or some data that was being rendered on to the DOM, so the user can interact with these data. So there are a lot of things that it's responsible for, but the limitation of what we have right now is that we don't have any class components, or we don't have any hooks, but uses the use state or the use reducer. So what I'm saying is that we don't have anything where we can get this like re-render, when we can force a change. So I'm gonna cheat a little bit, and I wanna so I can't what I'm saying is that I can't have an on-click event listener, for example, on the GSX and modify some state. So what I want to do is I want to sort of manually re-render outside of the React algorithm. And in order to do that, what I want to do is I want to manually attach event listeners, and manually add a button onto the a DOM structure, so I can manually call this render function. Later on, when we will have the class components, this is obviously won't be necessary, but until we get to that point, that's kind of a cheat how I will simulate changes in the DOM structure. So let's start by just simply creating a button. Like so, and I will attach it to the root element, and this is obviously not going to be managed by our algorithm that we're building, and it's absolutely fine. open child and button, and I also wanna have a text on it, so it's button and it's inner HTML equals so if I refresh it, you have this manually re-render. So it does nothing at the moment. I can click on it, but nothing happens. So let's add button add event listener. Click and re-render, and let's create that function. First, I just wanna console log things out to check whether it's working or not. Fine, so it listens to the event, and what I want to do is I want to call our render function with somewhat different JSX. Now let's call it with the same JSX for now, and I want to render it to the same root, because I just want to simulate, like I just want to change the JSX so we can basically update it. Yeah. Okay, so that's the first problem. So what I want to achieve is some update on the DOM element by changing the JSX. So what I kind of anticipated by just clicking on this manually re-render button is nothing happening, right? Because the JSX is pretty much identical. Instead, it's re-render. Not re-render. Instead, created new DOM elements on every click. So that's not what I wanted to do. But to make things more straightforward, I can put props on the native DOM elements, like on click, for example. Okay. Oh, and it's not working. And that is because yes, because the create state node has its own implementation of creating a state node, but we actually have a dedicated folder for that, and I think it's from yeah, because it's not const, it's import from DOM, and I think we have update DOM element and create DOM element. And if you remember, it's just simply, so create DOM element under the hood calls update DOM element, and update DOM element is simply attaching styles, event listeners, and every other prop to the DOM element except for the children. So that's what it does, and we were not using it in this file, so that's why it not got attached to the DOM element. But we can fix it by just simply removing some things here. So so instead of element, we're gonna treat it as a fiber, and if fiber, no, let's just simply return create DOM element, and it expects a fiber. So now it's got attached simply because we just swapped the underlying implementation. Later on, obviously, so this state node, as it's stated here, it can be either a DOM node or a React instance depending on the fiber type. So if the fiber type is a string, which is always going to be the case if it's a DOM node, like div, article, section, whatever you name it, then it's just simply create a DOM element. So it's going to be something like if the fiber type is a string, oops, it means it is a native element. So actually we can do something like fiber.type or type of fiber.type equals string, then return this bit, and we can later have if fiber.type equals object, and then it means that it's either a functional component, it's a class-based component, so we need to instantiate the React instance, so it's not gonna be this create DOM element. Okay, but now if I re-render, this should still work, so it's from JSX. Okay, but this sorry about that, just give me a sec. Okay. Yep. Okay. Okay, still working. So this means that I can attach styles to that div. So let's attach some style, some basic stuff like background color red, and it's red. So this is working pretty much as expected. But now if I come here and put background color like blue, instead of just simply changing the background color and remove the event listener, it's actually going to create another div, which is not the expected behavior, obviously. So what we want to do is just simply update the component and make the algorithm recognize that it's not another placement, but rather an update operation. Okay, so there are a few things that needs to be done. Okay, one of them is how we gonna so we need a way to compare the previous, because we could get away with the one kind of tree when we just made our initial render, and that's because you didn't need to compare things to any previous state. But when you doing any subsequent render, either because you force in a re-render or some state changed, then you need a way to determine, okay, if it's a new element, something changed along the way, or everything remained the same. And the way to do so is actually having two different trees, like one that represents the previous state, like and by the previous state I mean the previous fibers, and one that is like being built at the render phase. And the one tree that is being built on the render phase, the contents of the fiber will be dependent upon the previous tree. So it's not going to be like, okay, so just think about it. If you have the div in the given position of the tree, then it's not going to be considered as a placement, but rather an update. So the first thing we need is some way to store the previous fiber tree somewhere. So we don't have it now at the moment. So the okay, so when we have this, the earliest moment when we have the whole complete tree, like the fiber representation of the tree, not talking about the native DOM elements, but the fiber representation of the tree is when you painted everything. And when you painted everything is, so here is the painting phase. So when you, so this fiber effects as an array, and when you iterate it through all the effects, that's the point. So here, that is the point when everything is pretty much done. So this is the point when you have all your tree after the painting. So we can, and that's the root of the tree, if you remember. So that fiber, the committal work takes one argument, which is a fiber, and if you remember, this fiber is this pending commit, and the pending commit, if you come over here, is basically the currently executed fiber, but the currently executed fiber is after, it gets assigned after this while loop, and this while loop is iterating until there are no more parents. So that's only possible when we are in the root fiber. Okay, so the root fiber is actually the fiber representation of this div root. So, oh, that's quite a lot of information. Yeah, so the root fiber has a state node, which is this div element. And this is important because that div root is not rendered to the DOM by React, is rendered by some other method, either by a client-side thing or just HTML template. So what we can do is we can treat it as a stable point through our application, and we can say that fiber.state node, and by this, so if you remember that this fiber here is the fiber representation of this root, and its state node is actually this development, like, which has the ID of root. So that's gonna be, so there is no case, there is no possibility that this state node will ever go away. So we can say that root fiber container equals fiber. So what it does is it saves a reference to the fiber to the DOM element. So what we can achieve by that is the DOM element will be always available, and this fiber is like the most recent fiber. It has all the information regarding its child and siblings. So from this fiber you can access every fiber below, and it's never gonna go away. And by the time you get to the next re-render, obviously this is going to be obsolete because you will start building the fiber structure of the next upcoming re-render, but you will have access to the previous fiber structure on the DOM element, not the so yeah, it's always gonna be available. And if I just save this and I re-render this bit, this should be available on this div ID, and probably I can get it by, so if I wanna utilize the document object model, I can do something what I did in here. So I can access the root element and I console log out after the assignment. So if I console log the root out, this root should have this field and it should be pointing to this object. Okay, so I have the root, and if I have the root fiber container, then you see that we got back our root fiber basically. So by the time we console logging this out, this render phase, this render and painting phase is done, so everything is done. Just remember that we are here. Like, there are no more subtasks the pending commit is there, so we need to commit all work. But when we console login everything out, everything is done. So at this point, this fiber what we have here, like this is gonna be obsolete by the time you trigger a re-render. So just I'm going to trigger a re-render here, and this time this fiber is the representation of the previous painting phase. So yeah, that's the way how we can save, at least one way, how we can save the reference to the previous structure. And this is important, again, to be able to compare the currently so the fiber that we're currently creating and the previous fiber, so we can determine what is what should be an actual component creation, or just update some component, or component deletion. Okay, so also if we are here, if everything is done, we should clear the pending commit because we are done with the painting phase. Okay, so now we have an idea of how to save this. Now we need to utilize this information, and the way to do that is we need to, so this is a fiber, this is going to be the first fiber. We need to set the alternate to task.dom.root container fiber. So this way, on the first render, obviously it's gonna be null, and if it's null, we just know that everything is a placement. If it's not null, then we can need to make some changes along the way. We need to compare things, whether it should be an update or delete or a create method. Okay, so how we can actually utilize these things is another issue. Okay, so as we said, it will only have an alternate then if you only have an alternate if it was present in the previous cycle, right? So just imagine this scenario, that this app, like the fiber representation what we were going to build in the JSX, from the JSX in the render cycle, will have an alternate. And the way is that because a fiber will be in the same place from the previous render than it is in the current one. So the way to express it in the code is something like, we need to check that okay, so let me think about it. So it's fiber. So let's assume that we are rendering the div that contains that text element app. So here in the children, we have the JSX of the div, and the fiber in this case is the root fiber. So what we need to do is we need to check that if there is a fiber alternate, and if there is a fiber alternate, we need to check if there is a fiber alternate dot children, a child, sorry, because this fiber alternate child, if that exists, that's gonna be in the same place in the tree as this children, which is now only a JSX. So the reconcile children's responsibility is to create a fiber out of the JSX. But in the previous cycle, we already did that, and if we have an alternate child, that child is in the exact same position. So we can assume that in the previous cycle, this child was created from the JSX that had the exact same position. So if it is there, then we can say that alternate equals fiber.alternate.child. Okay, And what we can do, if we can say that, okay, if there is an alternate, then we can assume that it's not a creation, but actually it is a update. We can refactor the code later. I just wanna kind of make it work. So in this case, I have the state node. I don't need to create another one, right? So the state node is the host component, or the DOM component, in this case the div. So I don't need to create a new one. That's the whole point of update cycle. So what I can do is state node will be alternate dot state node, I guess. Parent will be file, and effect tag will be update for now. Okay, I think it's quite good. Okay, and now there is one more thing we should do. Is so the commit all work is always appending the child, but we need another case. So we just need to set that if item. So item is a fiber. So item effect tag equals update. In this case, don't append it. You just need to use this update DOM element function, which removes the old props and appends the new props. So it takes the state node, which is item.state node, takes the old props, which is item.alternate.props, I suppose, and the new props are item.props. Okay. The cannot read property props of undefined. Yeah, sorry. So because alternate should be alternate. I think this. Okay, that's quite good. So now we can see that it did not get appended to the DOM as a new element. Instead, we just modified it. So now instead of red, we have a blue color. And actually, if I click on it, hopefully there won't be any click listeners attached, which is not the case. I'm not quite happy about it. So the style changed, but the on-click had not. Which is a bit of a concern. That's interesting. So the problem could be from two places. One of them is we're not passing the old props here, so let's just console about what the old props are. Okay, so the old props. Okay, we definitely have an on-click listener. Okay. So we have old props, remove props, new props. What? So we remove the event listener on the, I think it should be old props here. I think it's just a typo, but let's check it out. So re-render, and now we don't have the GSF, the on-click listener. So what I just wanna check that if I add another onClick, whether it work or not. So resolve from new. So from JSX, manually render from new. Okay, so it got rid of the old event listener and attached the new one. Alright, so we got to a point where it detects if it's the same JSX. And I think that's gonna be enough for this video, but there are plenty of things to do, so I'm gonna continue the logic on the next one. See you until then, guys. Bye.